Earth system science is a complex mechanism that can be understood by making scientific observations on specific parameters like temperature and wind through different types of scientific observation. These two parameters are important meteorological variables that significantly affect the Earth system. Observation on ocean winds is one parameter which is amenable to the space-based platforms using instrument called scatterometer. The magnitude and direction of the wind vector at the ocean surface is a key parameter for weather prediction as well as detection and tracking of cyclones. ISRO earlier launched OceanSat-2 in 2009, which had a Ku-band pencil beam scatterometer as one of the instruments that provided good quality wind vector data until recently. The utilization of such data from OceanSat-2 scatterometer by Indian weather forecasting agencies has significantly improved the accuracy of weather forecasts and cyclone tracking in India. Many global agencies such as EUMETSAT, KNMI, NOAA and NASA also utilize the data for applications in their country. SCATSAT-1 is the second scatterometer of the similar kind that is scheduled to be launched on 26 September 2016 to provide continuity of such important services, meeting the national and global needs of the scientific community. The satellite structure has IMS-2 satellite bus heritage and weighs approximately 377 kilograms. Sun sensors, STAR sensors, magnetometers and the miniaturized inertial reference unit provide precise orientation reference to the satellite. The Attitude and Orbit Control System, AOCS-1, maintains the satellite's orientation with the help of reaction wheels, magnetic torquers and thrusters. The two solar arrays of the spacecraft generate about 750 watts of electrical power. The onboard thermal control is achieved by using passive thermal elements like optical solar reflectors, multi-layer insulation blankets, paints, and heat pipe embedded panels. The satellite is designed for a lifespan of around 5 years. The main instrument in this satellite is a Ku-band scanning scatterometer radar. It consists of rotating antenna subsystem, Ku-band transmitter, frequency generator subsystem, receiver subsystem, digital chirp generator and data acquisition and compression subsystem are some of the other major packages of the spacecraft. A scatterometer, in simple terms, measures the backscattered signals from the ocean surface. When the radar of the scatterometer emits electromagnetic energy pulses towards the ocean surface, due to interaction between the emitted electromagnetic energy and sea surface waves, these pulses are scattered back, which is called backscatter effect. By studying various properties of this effect, it becomes possible to derive information on speed and direction of surface winds over the oceans. As this information is needed to be gathered over the global scale in shortest possible time, the satellite antenna is also rotated for scanning the ocean surface along with the motion of the satellite with two beams, resulting in 1400 kilometers inner and 1800 kilometers outer swath or coverage. The data so collected is processed on board the satellite and stored on a recorder. It is later transmitted to the ground station and converted into wind vectors. Polar Satellite Launch Vehicle, in its 37th flight, will launch the SCATSAT-1 and its 7 co-passenger satellites. There are 3 Algerian satellites, the first being ALSAT-1B, which is an Earth observation satellite based on SSTL-100 platform for monitoring agriculture, environment and disasters. Second in line, ALSAT-2B, which is a high-resolution remote sensing satellite with panchromatic and multispectral imaging capability. And the third being ALSAT-1N, which is a technology demonstration nano-satellite built as part of the program for Algerian students. From USA, Pathfinder 1 is a commercial high-resolution imaging microsatellite. From Canada, NLS-19 CanX-7 is a technology demonstration nano-satellite built to perform experiments to help reduce space debris and for tracking commercial aircrafts. The remaining two satellites, Pratham from IIT Bombay and PISAT from PES University Bangalore, are from India. The main objective of Pratham is to estimate the total electron count (TEC) with a resolution of 1 km by 1 km location grid. The main objective of PISAT is to design and develop a nano-satellite for remote sensing applications. All these 7 satellites together, weighing about 294 kilograms, will also be launched by PSLV C35. Of the 8 satellites carried by PSLV C35, SCATSAT-1 will be placed in a 720 kilometers Polar Sun Synchronous Orbit (SSO) inclined at an angle of 98.1 degrees to the equator, whereas the other co-passengers will be placed in a 670 kilometers polar orbit of 98.21 degrees. This will be the first mission of PSLV in which it will launch multiple satellites into different orbits. It will be launched from the first launch pad of Satish Dhawan Space Centre SHAR, Sriharikota, and will be the 15th flight of PSLV in XL configuration. ISRO will also provide data collected by SCATSAT-1 from its website, and real-time updates will be available within 3 hours of data acquisition. Among various other applications, it will be highly useful for making accurate prediction of cyclone formation, its movement and estimated landfall, and thus directly lead to saving large number of lives globally.